All right, welcome to lesson 1.3 clip 2. And in this lesson, we are looking at being able to solve and set up equations that involve measures of angles and angle bisectors. In clip 1, we finished up with deciding whether these were angles or not, and now we're going to define what a degree is. A degree is a unit that measures the angles. It's a way to measure angles. It's a unit that measures angles. Okay, there's actually a couple ways you can measure with degree or gradient or radians. And in here we're primarily using degree, although we may look when we get to our trigonometry unit at some radians as well. A degree is, well, angles are thought to be part of, if you took this ray and rotated it all the way around, that would be 360 degrees or full circle. So 1 degree is actually 1/360th of a circle. So that's how degree units were derived. There's something called the protractor postulate. It's just like the ruler postulate. We don't really memorize it or use it in proofs, but we understand how it works. And that is that, just like a ruler, if I have a protractor and I have some points, so here's my protractor, up here's my 90 degrees, over here's my 180 degrees, and here's my 0 degrees. If I have some points that are on the protractor, and an angle, I don't have to line my protractor at 0. Now, in middle school, that's what you did. You always lined up one of these rays over here on the 0 degree, and then you could look and see where the other ray touched, and it went from 0 to that number. So let's say that this was at 40 degrees, and this one, let's say, is at 80 degrees. So this would have been 0 to 40, which is 40 degrees, this angle right here. But from 40 to 80 is also 40 degrees because there are 40 degree tick marks between 40 degrees and 80 degrees. So like the ruler postulate, which said if you had 2 points and you assigned numbers that were lined up on a ruler, that you could subtract them and take the absolute value to get their distance, you can do the same thing with the angles. You can assign, this postulate allows us to assign numbers from the protractor to points. Now that's assuming, though, that the vertex of our angle is sitting right there on the protractor and the crosshairs of the protractor. And then we can simply subtract them to the absolute value of their difference. The measure of angle 1 minus the measure of angle 2, take the absolute value, and that will equal your measure in degrees. So let's take a look at an example of this. But before we do, let's review some key vocabulary terms from middle school. Everyone knows that a right angle actually makes an L, like a left, like left. So there's a right angle. A right angle is 90 degrees. So that's where your angle is 90 degrees. So I write theta equals instead of x. When we solve for x, we're solving for sides usually, but when we solve for theta, which is a Greek letter, that's the variable, the primary variable that we use for angles. Now some textbook series will still use x to represent the angles, ours does, in certain sections in theta and others. And then the same thing will happen when you get to, well, actually in pre-calc or algebra 2, they'll use theta as well. An acute angle is an angle that's less than 90 degrees, but it has to be greater than 0 degrees. So it'll be smaller than an L. An obtuse angle is an angle that is bigger than 90 degrees. Well, I should write that differently. An obtuse angle is less than 180 degrees and bigger than 90 degrees. So there's bigger than an L, but smaller than 180 because 180 is half a full circle. So a full circle, half a full circle is a straight angle. For a straight angle, it is equal to 180 degrees. So right angles are 90 degrees, straight angles are 180 degrees. Obtuse is between the right angle and the straight angle. Acute is between no angle and the right angle. All right, example 2. Measuring and classifying angles using the protractor postulate. So this says find the measure of each angle, then classify it as acute, right, obtuse, or straight. So the first angle we're looking at is WXV. WXV are those rays that I've outlined in purple. Well, based on those rays, this number right here is 150. It's 150 degrees on the outside number. On the outside number here, this one is 180. So if I take the numbers that are assigned to them, I can do 180 minus 150, and that's 30 degrees. I could also have taken the inside numbers. This one's 30, this one is 0. So I could have done 30 minus 0 to get the same result. Just be careful not to mix your numbers. Don't pick an outside number and an inside. It either has to be both numbers from the outside or both numbers from the inside. For our next angle, angle VXZ. VXZ on the outside, again, is at the 180. On the outside of this one is the 50. So I have 180 minus 50, or if I used the inside angles, I could do 150 minus 0. Either way, I get, wait a second, 180 minus 50, and then 150 minus 0. Something's off with that. Hold on one second. It would help if I could read it. This is actually 130, not 150. This one's 150, that's 130. So 180 minus 50 or 130 minus 0, either way turns out to be 130 degrees. The next one, ZXW, I will trace in green. Z to X to W. Now those aren't on the crosshairs, or they are the vertexes on the crosshairs, but they're not lined up to 0 or 180 degree. The outside number is 150. The outside number on this one is 50. The inside number on this one is 30. The inside number on this one is 130. So I'm either doing 150 minus 50 or 130 minus 30. Either way, I get 100 degrees. Now I missed something here, and that was that we were supposed to also classify it. So I would, before I move on to the next problem, I would go back and make sure I answered all parts. Find each measure, which we did, then classify it as acute, right, obtuse, or straight. Well, the first one is a 30-degree angle, so it's acute. The second one's 130 degrees, which is bigger than 90 and less than 180, so it's obtuse. And the other one's 100 degrees, which is also bigger than 90 and less than 180, so it's obtuse. Please take a moment to try the other letters, C, D, and F, using the picture below. You should be able to see those numbers a little bit better. So I'll even try to zoom in on it a little bit so you can hopefully see that better. All right, for angle AOE, if I trace angle AOE, that is a straight angle. So it is 180 degrees, and I would just call it a straight angle. With angle EOC, highlight that one in pink, EOC, here's my pink ray, here's my other pink ray. It's a little tough to see. That's not quite 75, it's like 76. Well, actually it's like 104. And this one's on the outside at 0. So if you have 104 minus 0, you get 104 degrees. Or if you did the inside, which I have, it's 76 and 180. 180 minus 76 is also 104 degrees. It's a little hard to see, so if you were off by 1 unit, that's okay. So 104 degrees, which makes this one obtuse. And last one, angle BOD. So angle B, the outside number is at 140, and ray OD, the outside number is at 15. So I have 140 minus 15 gives me 100, or actually gives me, yes, 125. 125 degrees is an obtuse angle. So we have the angle measure and classifying it as obtuse, acute, right, or straight. Next, we're going to talk about congruent angles. And we mentioned this before, just like congruent segments have congruent tick marks, congruent angles have congruent arc marks, so there's a single arc mark. If I had another set of angles that was congruent, but they were not congruent to those, then I would use a double angle arc mark or triple angle arc mark for even another set that was congruent but not the same as the previous two. Congruent angles are angles with the same measure. And usually, for now, that measure is in degrees. But sometimes it could be in radians or gradians. We'll get to that later in the year. Just like we had the segment addition postulate, which was, hey, you got the whole thing and you got the two pieces, and this piece plus this piece adds up to the whole thing. We have the angle addition postulate, which says that basically if you add as long as the two angles are connected by a common ray and they're not overlapping, such as this one and this one, then we can add the angles. So it says they're actually called adjacent angles, and we'll get to that term in a second, add up to the whole angle. So in this particular picture, I have this green highlighted one, which I could measure with the protractor. I'm not going to. I'm just going to write M angle for the measure of angle ZWY plus, and then I'm going to have this purple one right here. Those two are touching. They're not overlapping, but they're touching. The measure of angle YWX. Those two angles add up to the bigger angle, which I'm going to highlight in orange, ZWX. The measure of angle ZWX. Notice we had Z and we had X as the ends on those rays, and now we have Z and X and W still the vertex. Basically what it says is angle plus angle, as long as they're connected and not overlapping, adds up to the whole angle there. So we're going to be using the angle addition postulate like we did with the segment addition postulate to set up and solve problems. Our first one just involves numbers, so we're just going to write an equation, but we are supposed to draw a picture if there isn't one. They have angle AB, measure of angle ABD. Wow, there probably should have been a picture for this. So I'm going to draw an angle, and I'll call this ABD, and that's 121 degrees for the whole thing. And they have ABC, and they really need to give you some descriptions on this because I don't really know where that is. I'm going to pretend it's right here, that C is here. So normally they have to give you a description saying C is on the interior of angle ABD, so I put C on the interior, and now I have that this angle plus this one adds up to the whole thing. This one's 59 degrees. What I don't know is the measure of angle DBC, so I'll call that X, Don't call it x if other things have x as a variable, but this one doesn't. So I have this piece and this piece and this whole thing. So x degrees plus 59 degrees equals 121 degrees. Some of you just said, well, let's just subtract. Yes, but we're supposed to set it up using the angle addition postulate. So now I will subtract 121 minus 59 is 62 degrees. So the measure of angle DBC is 62 degrees. This next one we're going to write as a proof for the next problem. We have measure of angle DEG, which is the whole angle. We have an expression for the measure of angle DEF, that expression being 5x over 3 plus 4. And we have an expression for angle FEG, that expression being x minus 5 all over 2. So now the whole thing is given as 125 degrees. If I'm supposed to write this as a proof, then I have to start with my first line being why I can write the equation. And why I can write the equation is the angle addition postulate. So I wrote angle add post for angle addition postulate. And the equation I'm going to write is that the measure of angle DEF plus the measure of angle FEG, the two smaller angles that are connected, add up to the whole angle, angle DEG. So the measure of angle DEF plus the measure of angle FEG equals the measure of DEG. Should have left a little bit more space. I'm going to here. So DEF is 5x over 3 plus 4 plus FEG is x minus 5 over 2, and that equals 125 degrees. I'm not going to put the degree symbol on just because I'm writing my equation. Since I plugged that in, that reason would be substitution, as we plugged in the expressions that were given to us. All right, now a lot of us don't like fractions, so you may want to get rid of them by multiplying everything by the least common denominator, which is 6. 6 times 125 is 750. 6 times 5 is 30. Divided by 3 is 10, so I have 10x. 6 times 4 is 24. 6 times that, but then divided by 2 is actually going to be 3 times x minus 5. So going from here to here, I multiplied everything by 6. I used the multiplication property of equality. Now I'm going to distribute. So I'm going to need to distribute. So I will have 10x plus 24 plus 3x minus 15 when I distribute the 3 equals 750. My reason being that I simplified. I just write distribute. Now I'm going to combine like terms. So that's going to give me 13x. 24 minus 15 is 9. So I've got plus 9 equals 750. I combined like terms, so in my proof I write CLT or simplify. Step 5, I'm going to subtract 9 from both sides, so 13x, 750 minus 9 is 741. I used the subtraction property of equality. Don't just put sub, at least put sub, start with the word subtraction so we know what it's going to be. And then I'm going to divide last by 13. So when I divide by 13, I get x equals 57. So we use the division property of equality. Now, if I go back up, they asked us to find the measure of angle FEG. Measure of angle, so I'm going to write that out here. The measure of angle FEG is x minus 5 over 2. And so I will be using substitution by plugging in our answer for x into the original expression for FEG. So my answer is 57. 57 minus 5 is 52, and half of 52 is 26. So we got our answer, and we did it in a proof form. Most of our problems are not going to be this way, but we're trying to get ourselves set up so when we get to proofs, they come a little easier. So we're practicing it with the algebra and how we set it. How do we set up the problem? We have to write an equation with expressions first for the angles, using a postulate or definition or theorem when we get to some theorems. All right, so that is it for the angles. We are going to talk in the next clip about angle bisector, and that will be it for the notes. You will not be doing any try-it problems on this. So please look at the next brief clip on angle bisector.